This week, students will analyze data in graphs in order to distinguish between weather and climate, and in order to understand some of the evidence for climate change. These two graphs have some features in common, but show very different data sets. We need students to understand the differences between them as well as the specific features of each graph in order to make evidence-based, scientific conclusions about weather and climate. In this video, we'll examine each graph to determine what it means in order to help students do the same. On page 4 of the student handout, we see a graph titled Comparing Weather and Climate Data. Beneath the graph are several questions written to help students scaffold their analysis and understanding of what the graph is showing. It's a pretty complex graph, densely packed with information. Let's go through the student questions to break it down. First, let's take a look at the axes. The horizontal x-axis is labeled time in months. Individual days aren't labeled, and it looks like every month gets more or less the same amount of space, even though months are slightly different lengths. The vertical y-axis is labeled temperature in degrees Celsius. Note that the y-axis does not start at 0. It starts at negative 10 degrees and then goes up to about 45 degrees. Each small tick mark represents a 5-degree interval. From these axes labels, we can conclude that this means the graph is showing us the change in temperature over the course of 1 year. What does an individual point on this graph represent? This might be confusing to students because the graph shows several lines, not points. What the question means is that if you were to place a point at some location on the graph, like here say, what does that represent? Well, if we examine the x and y coordinates of this point, we see that it represents a temperature of around 14 degrees Celsius during the month of April. Any individual point on this graph tells us the temperature in a given month. What do the two different colors represent? Looking at the labels on this graph, we can see that the red lines are showing high temperatures. The thick line shows the average high, and the thinner wavy line shows the daily high temperature. Conversely, the blue lines show low temperatures. Thick is average, wavy is daily. What are the trends in the lines? Trend is another word for pattern or overall tendency. It looks like the thicker lines have a positive slope in the spring months, peaking in the summer in July, then a negative slope in the winter months, with a low in January. If we could extend the x-axis of the graph, it's likely that we would see this trend repeat in a pattern. It's also interesting that the thick lines are roughly parallel at any point and stay the same distance apart on the y-axis. The thinner wavy lines are much more erratic, although they stay roughly parallel. The wavy line shows a similar rising and falling pattern as the thick line does, but on a much smaller time scale. Rather than rising and falling over the course of a year, it rises and falls over the course of days, with high and low spikes at seemingly random intervals. The graph is titled Comparing Weather and Climate Data, but which line is which? Here, students may get confused and try to assign a different color to represent weather or climate. But this question refers to wavy versus thick lines. Remember that weather changes from day to day, while climate is a consistent average over time. The labels in the graph help with this question a lot and confirm that the wavy lines represent weather, a daily change, while the thick lines represent climate, the average. So what does this graph tell us about the relationship between weather and climate? Well, for one, it reinforces the idea that weather changes quickly, often on a daily basis. On this graph, that is shown by the rapidly rising and falling wavy lines showing daily high and low temperatures. It also shows just how much variation there can be in a given location's weather. Notice how the spike in March's daily high temperature is higher than the lowest daily high in July. In fact, there's a lot of overlap across the highs and lows because there's so much variation possible in a region's weather. In March, it's possible that it will be as cold as negative 5 degrees or as hot as 20 degrees Celsius. However, the climate is fairly stable, shown by the smooth, thicker lines. In any given year, there's a huge range of probable high and low temperatures for this location. However, the average high and low temperatures are stable. It's likely that in January, the temperature will be somewhere between negative 5 and 5 degrees Celsius. In July, between 15 and 25 degrees Celsius. Another interesting thing about this graph. We can also infer from this that the location that generated this data is somewhere in the northern hemisphere, in a temperate zone. This is evidenced by the average temperature overall, which goes from around freezing in the northern hemisphere's winter months to around 20 degrees Celsius or 70 degrees Fahrenheit in the summer months. This is a complicated graph, and it will likely take students some time to parse all of the parts. To be honest, when I first saw it, I thought it was showing the daily and average temperatures of two different locations, one colder than the other. Only after going step by step through these questions did I realize that it was actually comparing the daily high and low temperatures to the average high and low temperatures in just one location over the course of an entire year. The daily and average high and low labels were key in coming to this understanding. The next graph that students analyzed this week is titled Global Mean Surface Air Temperature. It also has a thin, rapidly changing wavy line and a smoother, thick line, and it also shows temperature over time, sort of. But there the similarities end. Before, the graph showed one unknown location on Earth, somewhere in the northern hemisphere. This graph shows a global mean, that is, the average of the entire Earth. Right away, we see that whereas before the x-axis was showing time in months, this graph shows time in decades. Starting in 1880, the graph extends to 2020 in intervals of 20 years. Notable is that on this graph, the thinner line connects discrete points. In fact, there are 20 points in each labeled interval on the x-axis. That means that each point represents 1 year. In total, this graph shows a 140-year time span. In the first graph, the y-axis simply showed a temperature in degrees Celsius, much like a thermometer. This y-axis is more complex, instead showing the temperature anomaly in degrees Celsius. The interval of the y-axis is 0.2 degrees, starting from negative 0.6 degrees and increasing to 1.0 degrees. So what is this actually measuring? What is the anomaly? Here, 0.0 degrees represents the average global temperature for the whole time period shown. A point below 0 represents a year in which the global temperature on average for that year was below the global temperature on average over this whole time period. Any point above the 0 line represents a year in which the global temperature on average for that year was above the global long-term average. This graph shows a clear trend. Global temperatures have increased dramatically since 1880. The annual mean, that is yearly average, varies a good deal over any given set of a few years, but over the course of 140 years, it shows a consistent trend upward. The thicker red line, an average of averages, shows this even more clearly. And not only have temperatures increased, but the rate at which they have been increasing is also itself increasing. That is, global temperatures have been rising faster and faster over the last century. Although these two graphs have some superficial similarities, they're really quite different. They're also both extremely complex and full of information. It's likely that students will require some guidance when analyzing and interpreting them, and the scaffolded questions in the student handouts will help them make sense of that data one step at a time.